All right, so this is the key to expressions worksheet 1. And so you have, in this case, you're dealing with complex numbers, the imaginary units that have the imaginary units I in it. And so you want to perform the indicated operations, and you want to write the answer in the form a plus bi, okay, into that complex form, a plus bi. So you have the real part and you have the imaginary part. So let's get number 1. So number 1, you have 2 times 3 plus 5i minus 3 times 2 plus 7i. All right, now remember though, I is not, I is an imaginary number. Remember, I is equal to the square root of a negative 1. The square root of a negative 1 is not a real number. All right, but when doing these problems, you can think of I the same way you did your variables. You did with when you had variables here. So if this was the variable x and this was the variable x, then the first thing you would do is use the distributive property. Same thing here, right? It's just that this I is, even though we're using a variable, it really means something. It means that I is that square root of a negative 1, which is not a real number. So if I distribute, this is what I get. I get 2 times 3 is 6. So that's going to equal 6. 2 times 5i is 10i. And then distribute the negative 3 here. I get negative 3 times 2 is a negative 6. And then negative 3 times 7i is a negative 21i. Combining like terms, 6 subtract 6 is 0, right? And then 10i and a negative 21i is a negative 11i. And there's your answer. You wrote in the form a plus bi. Now, if you wrote it as just negative 11i, that's fine. I would have given you credit for it, although this is the form a plus bi. A in this case is 0, and then bi is negative 11i. Okay? All right, number 2, you have 6 minus 5i times 2 plus 3i. So you have two binomials here, and notice though, I is not, although we use I as a variable, I is not a variable like you would think this was an x or y or an a, whatever variable you may use. I is an imaginary number. All right, so it's equal to the square root of a negative 1. But I can use that same idea where I can use that FOIL method. So if I use FOIL, 6 times 2 is 12. The outer, 6 times 3i is 18i. The inner, the terms on the inside, negative 5i times 2 is a negative 10i. And then the last, negative 5i times a positive 3i is a negative 15. Negative 5 times 3 is 15. Now remember, I times I is I squared. Okay, so that'll be minus 15 times I squared. And remember, I squared is equal to a negative 1. So that was one of the things you learned in those lessons. Okay, so if I square both sides, I get this. And so we're going to combine like terms. I have 12, 18i, and a negative 10i are like terms. So that's going to be a positive 8i. Now right here, you want to rewrite that I squared using that negative 1. So this becomes minus 15. Remember, this says 15 times I squared, so times, so that's 15 times a negative 1. This I squared is a negative 1. And so now this becomes 12 plus 8i. A negative 15 times a negative 1 is a positive 15. Combining like terms, I can combine those constants. 12 and 15 is 27, so I get 27 plus 8i. And so that is the answer to number 2. Number 3, we have 6 divided by 4 plus I. Notice that in this problem, the number I said variable, I meant number, I is in the denominator. So what you want to do there is get rid of I that's in the denominator. So when in the lessons, when we talked about something like number 3, we talked about the fact that we need to get rid of this I that's in the denominator. We need to multiply both both the numerator and the denominator by the conjugate of this complex number. So remember the conjugate of 4 plus I is 4 minus I. So all you're doing when you put in the form a plus bi, you're just, if you look at the bi term, the imaginary part, you're just changing the signs. Plus becomes minus. All right. And so what you want to do at this point is this. So you're going to multiply both numerator and denominator by the conjugate. So the conjugate of the denominator is 4 minus I. And so now you're going to rewrite this to look a little bit better. So you're multiplying two fractions. So let's write this as one fraction. So this says 6 times 4 minus I. And you got to put 4 minus I in parentheses because both of those has to be multiplied by 6. And then the denominator you have in parentheses 4 plus I times 4 minus I. All right. Now let's distribute. Let's go ahead and get rid of the parentheses in both numerator and denominator. In the numerator, I can just use the distributive property because this is a binomial being multiplied by a monomial. So the distributive property works easily here. So I get 6 times 4 is 24. And then 6 times a negative 1i is a negative 6i. The denominator, you're multiplying two binomials, so we're going to do it just like we did this. We're going to use the FOIL method. So when I do that, I get 4 times 4 is 16. The outer, now in the lessons you notice that when you multiply complex numbers that are conjugates of each other, the outer and the inner will add up to be 0. So go ahead and make sure that happens. So 4 times negative I is a negative 4i. And then the inner, 4 times I is positive 4i. And notice those add up to be 0. Now the last, a positive I times a negative I. Remember, a positive times a negative is a negative. I times I, we saw earlier, I times I is I squared. So it becomes I squared. And then I get 24 minus 6i divided by 16 minus I squared. Remember, I squared is negative 1. So replace I squared with negative 1. So then this becomes 24 minus 6i. And then I know that 16 subtract negative 1 means 16 plus change subtraction to addition. So you're going to add the opposite, and the opposite of negative 1 is a positive 1. So now this becomes 24 minus 6i divided by 16 plus 1 is 17. But remember, you want the answer in the form a plus bi. So you're going to write this as two fractions. So this becomes 24 divided by 17 minus 6i divided by 17. So here's a, and then here's your bi. All right, so that's number 3. Okay, number 4, the very last one, we have this time. So number 4, we have 1 plus 3i divided by 2 plus 5i. So remember, you don't want I in the denominator. You don't want that imaginary number in the denominator. It's okay to have it in the numerator, but you don't want it in the denominator. So that's why you saw here I had the imaginary unit in the answer just being in the numerator. So it was not located in the denominator. In fact, my denominators were rational numbers. Okay? All right. So what you want to do is you want to rationalize this denominator. So you want this to be a rational number. Right now it's not a rational number because of that imaginary unit right here. So you're going to multiply, just like in the previous one, you're going to multiply both numerator and denominator by the conjugate of the denominator. So my denominator is 2 plus 5i. The conjugate of 2 plus 5i is 2 minus 5i. That's a conjugate. So you're going to change the sign of the imaginary part. And so now we're going to multiply both numerator and denominator by that conjugate. And by doing that, by multiplying the numerator and the denominator by the conjugate, when I multiply those denominators out, I'm going to end up with a rational number. I'm no longer going to have an imaginary unit there. All right, now this time though, remember just like the previous one, you wanted to write this, you want to go from here to one fraction. Same thing here. So you're gonna rewrite this as one fraction. So you have to multiply the numerators together. But notice this time you have a binomial and a binomial. So put that in parentheses. 1 minus 3i times 2 minus 5i. Same thing in the denominator. You're going to write this as 2 plus 5i times 2 minus 5i. Okay? And in both cases, I'm going to have to use the FOIL method. I'm going to have to use FOIL. Whereas when we did this one in the numerator, I just had to use the distributive property. But in the denominator, I used FOIL. Okay, so let's go ahead and do that here. So, first outer and less. My first, 1 times 2 is 2. My outer, 1 times a negative 5i is a negative 5i. My inner, the terms of the inside, negative 3i times 2 is a negative 6i. And then the last, now be careful, a negative times a negative is a positive. 3 times 5 is 15. I times I is I squared. So be careful with the last here. So when you do the last, you should get positive 15i squared. The denominator, same thing. 2, the first, 2 times 2 is 4. The outer, 2 times a negative 5i is a negative 10i. The inner, 5i times 2 is a positive 10i. Now remember, those are conjugates, right? So we talked about the fact that when you multiply factors that are conjugates of each other, binomials in this case, or multiply two complex numbers that are conjugates of each other, the outer and inner, when you do the FOIL, will add up to be 0. Now, just like we did this one, to get 15i squared, be careful with the denominator. A positive times a negative is a negative. 5 times 5 is 25. I times I is I squared. So positive 5i times a negative 5i is a negative 25i squared. Now at this point, I'm going to go back to the numerator, and then I'm going to go back to the denominator, and I'm going to combine like terms, and I'm going to use the fact that I squared is equal to a negative 1. All right, so let's go ahead and do that. So the numerator, I get 2, a negative 5i, and a negative 6i is a negative 11i. Plus 15, and then I squared, so 15 times I squared, and I squared is negative 1, so 15 times I squared becomes 15 times a negative 1. The denominator, I get 4 minus 25i squared, so that's 25, and I squared is equal to negative 1. So it becomes 4 minus 25 times a negative 1. Now let's simplify the numerator. So the numerator, I have 2 minus 11i. 15 times a negative 1 is a negative 15. And my denominator, I have 4 and a negative 25 times a negative 1 is a positive 25. Combining like terms in the numerator and the denominator, 2 and a negative 15 is a negative 13. So this becomes negative 13 minus 11i. The denominator, 4 plus 25 is 29. Before we go on, notice that I went from a number that had I in the denominator to a fraction in which the denominator is a rational number, so there's no longer an I. But this is not the form a plus bi. All right, so what you want to do is write it as two fractions. So it becomes negative 13 divided by 29 minus 11i divided by 29. So that's the form a plus bi. So this is your a, and this is your bi. Okay? All right, so that is the key to the expressions worksheet 1.